All right, hello everybody, it's me again. And today I'm here to talk to you about the background. The background in React Native. Basically, in a few words, when we are talking about the background, is everything your phone or the app in your phone is doing while you are not using that app. So you will not be looking at the app, you will not be using it, and we still can perform some work on the background. Because as we are coding in React Native, we are targeting those mobile devices and they are capable to do so. So let's see today some examples on how can we do this. First, I'll introduce myself. I'm this guy. As I said, I work at CallStack. You can find me by this nickname, Ferran NP. It's everywhere. I can register anywhere with this nickname. It's pretty okay. So as every talk I give, I like to ask why I'm giving this, right? Why I spend time to talk about it, and why we should care, right? And as we are React Native developers, as I said, we are targeting more than the web and the DOM. We're targeting mobiles, right? So I think it's worth saying that we are not just web developers anymore, right? We are kind of mobile native developers. So that is why I think background is important, and that is why I'm talking about this today. And few things about that background you can do, few awesome capabilities our phone has. For example, location. You can access location on the background, you can track the user location live, you can set geofences, so areas the user enters or lives. You can set a reminder if they are close to store and they need to shop something. Of course, audio, one of the examples is going to be about audio. You want to play music, right? And if you build a player like we saw before in Raul's talk, you need to play music in the background. If not, this app is pretty useless because, I don't know, if you use Spotify or anything, you will not be looking all the time while it's playing, right? You will close the app and you will be good to go. We have gyroscope accelerometer. Those are just some sensors. For example, you can detect some gestures if your phone is in the pocket. Even your hair rate, you can monitorize for that on the background. And if your hair stops, for example, we can call the police. And probably if your hair stops, you will not be able to open the app. So that is good. When I was doing this talk, actually I saw this tweet and it was quite funny for me about progressive web apps will replace native apps and like everything is broken. I will not enter this discussion. You can ask Ken Wheeler. But I just want to remind you that, you know, we are mobile developers, so we have access to all these APIs and capabilities I just showed you before. And as we are building mobile apps, I think we need to be aware of everything this app is composed of. And I'll show you difference between Android and iOS because unfortunately they have a lot of difference in terms of background. And we will need to know them if you really want to build for both. So on Android, for example, we have services, we have broadcast receivers, we have content provider, widgets. All that stuff is built on the platform and you can access those also with React Native. But I'm going to focus here on services because basically on Android services are running on the background, and this is what is interesting for us. And then we have iOS, which it's not my field of expert. I used to develop on Android, not iOS. So I also need to know how iOS works and if it can do some work on the background. And it has these so-called background modes. And you will see the difference between these and Android services, and it's huge. They are quite limited. You can do a few things, and this is probably why the iPhones have a lot of battery. We have other stuff like Touch ID, Face ID, so you could lock your phone or make online payments with it. But we will focus on those background modes and Android services. And of course, because we are building in React Native, we get this React stuff that we all love, so we can build components in React, the UI, and they will look and feel the same for Android and iOS. And not only that, but we also get almost all the NPM package you love, like if you would like to use Redux, MobX, style components, you can also do it. And of course we get to React Native, which I like to say is just a wrapper for native code. with a bridge. Okay, so let's get a bit more theoretical and what's going on when your app really goes to the background. First, I want to understand this before start trying to run JS code on the background. And as I said, it's really different between Android and iOS, and we cannot change that. We cannot do some magic because we are in React Native. We want to skip this. No, we need to follow the platform stuff. And I prepared some diagrams to understand this. So we have here React Native. It's the virus, I call it. Why I call it a virus? So it's kind of weak virus, and it cannot survive if it's not attached to something, if it doesn't have a host. So in this case, it would be your Android application or your iOS application. And we will see then we can write native modules, or also we could try to run, if we could make this virus to be attached to the Android service, then it might be possible to run the JS code on the background. So let's see if it's possible. The Android way, services, right? So I don't know, maybe you want to fetch something or do some expensive operation, and if you don't do it in the background, which is pretty important on Android, it's probably not going to work. On Android, when you rotate the device, the app is destroyed and recreated. So if you don't do that work on the background, it's gone. So basically, if you would like to achieve this with React Native, you kind of need to communicate to a service that will do the work for you. There is other ways to start a service, but we will focus on React Native. So right now, if you would init a React Native app, you could start a service, but your React Native is kind of attached to the app, and under it's called activity. So here it would be our first problem, right? Because if you kill that app, our React Native is also going to die. And this doesn't mean that our service that runs in the background will die. It's still there, but we got the first problem here because we are not able to communicate anymore or to run JS code anymore. So we will see how we can overcome this. There is the iOS way, which is, as I said, more limited, not so free as services, but it's kind of easier to understand. It's that simple because actually when iOS runs in the background, it's not a service, it's the whole app wakes up on the background. So it's completely different. So here is the way we communicate directly to the app instance. I set the background modes there, but still I'm not using it. So the same, if you would kill the app, React Native will be gone, but background modes are capable to wake up your app, so your React Native code, and we will see those on examples. Actually, those iOS background modes are these ones, and only these ones. So if you want to do something on iOS in the background, you would need to activate one of those. The ones I highlighted, audio and background fetch, are the two examples I will show you today. So, I think we have a lot of theory, and we'll have more with a concept that is called headless.js, which is documented in React Native. But let's go first with this example, playing music. So again, you saw previous presentation, building a music player. So probably in that player you could use those capabilities so it can continue working on the background. And it's pretty simple, you know. On the web, we have this audio API, so we can just go and use it, right? So if you want to do this with React Native, you need to use something from Android or from iOS that it's capable to play music for you. There are tons of libraries out there, which are actually native modules. I use this one because I just like the code and I like the way it handles the background stuff, especially on Android where you are responsible to start it and stop it, especially on to stop it. So I built this app. It's pretty simple. It uses, you go React Native init, I install React Native paper, which we maintain on call stack. I install this library, React Native Music Player, I link it, and you can play 30 seconds songs from Spotify API. I will share the code later. And on iOS, under the hood, it uses this media player. On Android, under the hood, it happens that it's also called media player, but it's totally different. And if you would check the media player on the Android documentation, it's totally insane. It's a bit bad. However, because if it's Android, you could use other players that are open source, like Exoplayer. And this library is nice because it allows you to choose which solution under the hood you want to use. So how can we use this on our React Native app, right? If you have experience with native models, this is what we basically do here. We're gonna call setup player, and of course, because it goes through the bridge, it needs to be asynchronous, so we can wait for a response if it's okay, it's init, or it fails. And then the platform, iOS or Android, they will do totally different stuff. This is this nice Objective-C code. So this is the way you export a method. No? On iOS, if you want to write a native model, there is React extern method, and it's called setup player. And if you dig deeper, in this case it's Swift, at the end what it happens, it will start a session with this AB audio session. So this is how on iOS you would start a session. You send this setup player command through the bridge, and it sets up the audio session. We didn't touch the background mode yet, but we will. And then on Android, it happens we have this beautiful Java, and the name is the same, setup player, and you export it with React method, and it does completely different things. But the important thing is that at some point, if you check the code, you go deeper, there is this start service. So basically, you don't even know that, but if you use that library, it's going to start a service to run the player, so it will be already running on the background. And it's important we know that, because as I said, we need to be careful with running stuff, stopping them when necessary, take care of the battery. So on Android, it works something like that. You call the setup player, the same on iOS, and the other stuff will be transparent for you, right? So you start the service, and the service is responsible to start a player, media player or Exoplayer. And all the other commands, they'll work more or less the same. They are calls through the bridge, and on Android in this case, it will communicate to the service through the activity, and on iOS directly. So we don't care about that right now, we care about background. So what's on iOS? I said it's limited and so on, but it's easier. You would open Xcode, you would say background mode capability audio, and when you minimize your iOS app, it will already run on the background. And even you wouldn't need to do this if this React Native link can do it for you, but this library says, oh, running in the background is optional, so you got to do it, and it would work. On Android, it was already working, because you already started the service. But as I said, you need to take care on stopping it. iOS will do it for you, but here, you cannot let the service run forever. So of course, if you want to kill it, you would expose a native model, which this library has, and at some point on the code there is service stop self, and this will stop it. So you could actually call it from React Native. You could call destroy, and it will destroy the service. However, this is not usually the way you would do it in the music player. You would actually have something like this, right? You have a notification, or the built-in on iOS. So basically for the notification, you will swipe it and it will kill the service. And actually all of this library gives it to you. You don't need to do anything. So here there is no React Native involved. And later, when I talk about Headless.js, I will show you we could do something here with Headless.js, but we will see if it has sense or not. You can check this example here. It's open source. Probably it's not production ready with a lot of edge cases, but if you want to play with it, go on. Now there is the other example, which I found more interesting because I basically need it in real app that I'm building, and it's about syncing the data in the background. This app is basically a TV shows app where you can follow some TV shows, and what I want is that because I'm using external API, it's not my server at all. What I want is that sometime it needs to fetch data. So what I would like is let's say every day, my app wakes up and I could run some JS code to fetch data. And I would like this JS code to be the same on Android and iOS. So first thing I did was exploring this Android headless JS, which is documented on React Native from version 0.36, I believe. And what is this headless JS basically? So it's a way to run JS code without the need of opening your app. And this is what I need. This is what headless JS is doing. How it works, you can check the code on React Native GitHub, but it's simple, it's just a service. So they extend service class, in Java you extend service, and it does some stuff, right? And if you dig deeper into this code, for starting JS tasks, there is at some point a call of create React context in the background, right? So this React Native virus I was talking before, it has something to be attached, which is going to be that service. And this is the way with headless JS we can run this JS code on the background. To set up the headless JS, you just check the docs. You need to extend that service, so you still need some native work. We will see how to handle that. You pass the name of the task, you could pass parameters, and you have a timeout here. So you can see there is already a limitation on time. So you say this service should run for this period of time. And then there is this flag about task is allowed in the foreground. This is pretty confusing for me on the docs because it's like, okay, if you run that service while you are using the app, it might slow down the UI. So you might say, okay, I don't care, or I care. You have to check it out. By default, it's false. You can set it to true. And of course, because it's Android, if you want to run a service, if you want to run code on the background, you need to add that line on your Android manifest. And then, on the JS part, you would have your model. And probably you recognize this app registry. It's the way you register your whole app, right? So in this case, you can register this headless task, which is the model I created above. That sync code is the code I want to run for both platforms. And then I just give the name I gave on the native side, the same. But I had a problem here. So it seems everything is nice, but when do I start it? When do I start this service? Because I read this on the documentation. Now you can start the service as a periodic task or response to the system. So what I wanted to do was to run this code every 24 hours. And I didn't know how to do it. Fortunately, I did this on Android before. And on Android, there is an API. It's called Sync Adapter. And this is something we need to know too, because it's used by almost all the apps, like Facebook, WhatsApp, anything. Okay, why they use this? Well, it basically takes care of everything for you. You can schedule periodic syncs, so every day, every 4 hours. It checks the network connectivity. So if there is no network, it doesn't even try to do it. But the most important is about battery performance. It will try to schedule everything together, all the syncs together, so it doesn't need to wake up your phone that much. And you will not be able to do this manually, because how do you know how often Facebook wants to sync, right? But Android will know. And it will also take care of if you restart the phone. If you would try another APIs of Android, when you restart your phone, everything is gone. You need to set it up. So this is handled. So what did I do? Okay, so I created native model for this. It's open source also, you can check it out. It's pretty simple. I had the Android acknowledge, so you just write all the code. And then I had to expose something. But first I need to do something. So this code, what it actually does, it starts this headless service that I talked before. And this headless service runs my JS. If you want to use this library, it's just install and link it. And one of the good parts is that you will not need to write any native code anymore, because this library does it for you. And you use it like this. You import it and you call init. With the time, this sync interval, which can be every 24 hours, And this flex time with this, it's saying to Android, you have, for example, 2 hours, so you can do it every 22, 23, whatever, so it takes care of the battery performance. So this is the block of code, and you register the headless task, and as I showed before. And because we are using this library, the task list need to be named this way. So if you are curious how it works, it's a lot of code inside, but at the end there is an init function in Java which is exported and you can call. And somewhere deeper in the code there is onPerformSync, which is going to be called every whatever time you set up, like every 24 hours, and it just starts your headless service that React Native gives to you, which will run JS code. So thanks to a native model to the official API of Android, headless.js, which is just a service, we can run the JS code on the background, and I can do exactly the same thing I was doing with pure Android app. And if you use the Sync adapter, you can actually go to your phone, user accounts, and you will see all the apps that use it. And you can actually, the app I'm doing is called Showman, you can actually click, and you can click Sync Now, and you can watch your JS run. If you are interested on how you can write a native model like that, I wrote everything in this blog called stack.io, so you can check it out. And before we see how can we do the same on iOS, I wanted to ask if this headless.js nice thing makes sense on the music app. And my quick answer would be no. First, because it has this timeout. And I don't know for how long you want to play the music, right? I could use the headless.js maybe in this case when we have a notification. We click, for example, pause it, and I could run a headless task that actually communicates with the running service for a music player. But as you can see, all this is kind of overkilling it. Why would you do this? Especially when you click a button on the notification, it needs to be fast. So it doesn't have sense at all. It's better to have, in this case, direct communication, and the library, the music library I show you, it gives you this already. So headless.js is nice, but you need to be sure when to use it or not, so you need to understand. Okay, so for my sync example, it has sense. So let's try it on iOS, because what about iOS headless.js, yeah? You saw the product panes before, and there is this one, which have a lot of requests. Where is the headless.js for iOS, yes? And I think it was last month or so, there is this guy, Chris Scott, and he created React Native background fetch that we will be using, and he said there is no such thing as background service on iOS. And now that I was preparing that talk, it makes sense. Yeah? There are no services, it works different. Your app gets all woken up on the background, so there is no such concept of headless.js on iOS, and probably this product pain will never be resolved. So he suggested you could use my native model, of course, so I wanted to try it. Just let me show that slide so we can keep this in mind. There is no iOS headless.js, but there are background modes, and one of them is iOS background fetch mode, right? I showed it to you before. You can go to Apple Docs and read about it. Better or not, because they are a bit bad, but there is this line that it says with this, you can regularly download and process small amounts of contents from the network. And this is exactly what I needed, right? And actually this background mode, it also gives me nice stuff like this Android Sync adapter. It checks network availability, it checks the time and the data you did in your previous attempts, so it can do some battery performance stuff too. However, it has a limitation on this case, and it says you cannot schedule something more often than 15 minutes, so it needs to be 15 minutes minimum, not every 5. And the amount of work you do needs to last maximum 30 seconds. And if you skip that, this iOS OS will punish your app. Probably it will not let you run it again. So I didn't write a native model for this because it already exists and it's pretty good. It's React Native background fetch. You could also install it and link it. And then, as we saw on audio, you should go to Xcode and check this background mode, right? But here is not necessary because the link, in this case, it has a post-link script and it's actually capable to change your iOS file, which is called PLS in this case, and it can enable background fetch capability for you. So you need this enable, and now let's see. What we can do is import in this background fetch, and again we will call expose method configure. We will pass the minimum fetch interval here. I think this is 240 minutes, and you could use, for example, a timeout, so you are sure that every 30 seconds you stop it. And here is the nice stuff where it says sync code. This code is going to be the same I use for Android. In my case, this 30 seconds limitation is not a big deal. If it was for you, you could split the download in several parts, right? So maybe if you were wanting to do it every day, in iOS you can set up a smaller interval, so you can do it 4 times per day. So again, under the hood, we have the expose configure method on iOS, and at some point, this is how natively works. When this sync hits, it's time to sync, it will call perform fetch with completion handler, and at this point your app will be already woken up on the background. So it's capable to run your callbacks, which is your JS code. So I was able to do the same for both platforms with React Native, which when I started, I think a year ago with it, I didn't know if it was possible. So that was a success. Also, as you saw on Android, you could simulate a sync, you could do it manually. Here, if you have your React Native app connected, you can debug it with Xcode and you can simulate background fetch. You will see how it's called and how your JS runs. And that would be it for this example. And after that, we can see that, well, actually I can use everything from those APIs natively. For example, on Android, we have this broadcast receiver. What is this broadcast receiver? Well, this is actually in the React Native docs. You could, for example, listen for Wi-Fi got connected and do something about it. So you could listen for this Wi-Fi connection, start a headless JS service, and run a JavaScript task. Of course, it will need some native stuff, right? Because you need to set it up. But at the end, it's like everything started with React Native, right? At the beginning, it was more painful. Nothing was done. But now, almost everything is there. You have all those libraries that do the job for you, like the Sync Adapter one. So I know this talk was about the dark side of background tasks, but there is no dark side and there is no magic. I just use what your phone is capable to do, but we need how to do it right? Because as I said, we are mobile developers. We are not only web developers, we are mobile, and we have this access to the native capabilities. So there is a bit of work at the beginning, but as you can see, it's worth it. So I hope you enjoy this. Thank you very much.
Any questions, guys?
Thank you for the talk, and I have one question. I'm here. What is the best choice for GPS tracking on Android devices? So if I want to implement an application similar to Uber, like have drivers who has this background GPS tracking, what is the best way to implement this?
Yeah, so probably you need to have that service running all the time, right? So it's tracking the GPS and saving it, the position, and then when you open the app, you can connect to that service and show what's happening there. But running this headless JS, is you mean this, again, you have the problem of the timeout, right?
And if it's okay for me to update location every 10 seconds, will headless JS be useful in this case, or it's in any case, it would be better to use like separate all time running service?
I think it will be better the service, because if you want to spin up and spin down the JS every X seconds, probably phone will die.
Okay, yes, thank you.
No problem.
Еще вопросы?
Any more questions?
Hey.
I have a question about 15 minutes.
Uh-huh.
If my application is in an iTunes store and it's fetch data every 5 minutes, so what the Apple will do? It will ban my app.
So
and
the
it will never be-
system will ban your app. Yeah, it will. If you do it once, it will say okay. So now I give you every 2 hours, and if you continue to do it, it will just not do it. And if you don't stop it every 30 seconds also or less, it would also ban you. There is in the Apple docs, it's all explained there, and it's important. It's bad, but it's this thing. Yeah, you need to run it maximum every 15 minutes. Yeah.
Еще вопросы?
I have a question. What about using the ground for uploading some content, video, audio? Is it works?
For uploading.
Yeah, for uploading from mobile device, from some cloud, in foreground.
Yeah, you can spin up this headless task and upload something, and when it finish, stop it. And actually, it's a good idea, because if you kill the app and your upload is not finished, it will not finish.
And in this case, we have the same limitations for 15 minutes, yeah?
But the 15 minutes is about periodical tasks. Yeah? If you want to do this every 15, if you want to do it one time, you don't need this stuff. You can do it differently.
Okay, okay.
Еще вопросы у кого-то есть?
Yeah.
Окей, thank you, Ferran.
Thank you.
Thank you.